Well, hi everyone. Sorry, this is better. Test. Yeah. Thank you for coming to my talk. My name is Marko Miloš, and I come from Undabot, which is a mobile apps development company. And today I'll talk about clean architecture on Android. And first question, why would you need something like that? Well, I believe that most of you are working on the apps that are continually updated in terms of adding new features or updating existing ones. And along that way, you don't want to be a guy that writes 700 plus lines of code along activities, where you can find everything from dependency creation code, networking, business logic, animation scheduling, and so on. That kind of code will break other parts of the system when you don't expect it, and sometimes you won't even be able to tell if something is going to break other part of the system when you're making some changes. And that's bad because your code and project quality is not measured by only by its production stability. It's also important how fast you can iterate in terms of adding new features or updating something. And clean architecture here can help you fight these problems by achieving the following. The first thing is that the architecture is not dependent on the existence of some library, and that means that you can use these libraries as tools and switch them easily if needed. And also you won't be bound by the limitations of libraries itself. The second one, the business logic can be tested without the UI or concrete storage implementations, and know that that's important on Android, especially where testing the UI or anything related with the framework is hard, at least. Of course, you will be able to change the UI and your storage logic and database without affecting the rest of the system, which is your core business logic. And in the basically, your business rules won't know anything about any external agency, which are your libraries. Okay, and this sounds good, but how to achieve something like that? First of all, we'll need to follow the dependency rule, but before defining that rule, let's take a look at the famous onion-shaped schematic, where in very center we have entities, and these are your models, your classes and data structures that define the core business logic elements of your app. On top of that, you have use cases that work with these models, and they're here basically to define the business rules of your app, and they're orchestrating the data flow, and they're also called clear interactors in clean architecture, and it's just a naming thing, and you'll see in the future slides that I'm calling my interfaces interactors and the concrete implementations use cases. And at the bottom is abstraction, which is a higher level abstraction for framework-specific components. An example of that would be a repository or any other data provider. Then we have that data provider implementation and repository implementation. And at the top is a presenter, which is responsible for receiving the input from the UI, orchestrating use cases, and basically passing and formatting data for the UI that will then display it on the screen. And last layer is the UI itself. This is where your activities, fragments, adapters, and UI-related code resides. And at the bottom, we can see the data source, which is implementation of a data source like network or database. And dependency rule says that inner layers shouldn't know anything about the outer layers. And but not knowing anything, what's actually meant that you cannot use any code that's written for the outer layer from the code that's written for inner layer. And also, another important thing is that changes that happens in outer layers shouldn't affect the inner layers or shouldn't request the code changes for the code that's written for the inner layer. Okay. Now the question is how to write a code for something like that. And basically we'll split this schematic into 3 layers, and there can be more than 3, but if you find it useful to split one of these into 2, but common approach is to go with the 3 layers, and therefore for the sake of this presentation I'll stick with the 3 layers, where in the very center we have a domain, and this is where the entities and the use case implementations are. This use case will operate upon these entities, and they will talk with abstraction, and that abstraction is written for outer circles. At the bottom we have the repository implementation and data source implementations, and the top is the UI itself, where the view and presenter interfaces and their concurrent implementation resides, along with the other Android-related code. Okay, and I'm going to talk about each of these presentations separately and show you some code snippets in order to make you better understand what roles are we having here. Okay, first one is a presentation. is the most top layer, and basically in clean architecture this sits upon the model view presenter pattern, where the view is responsible for receiving input events and passing it to the presenter, and also to for scheduling animations and do all the UI related jobs. And the presenter here is responsible to act as a middleman between the view and the model, and that model is part of our domain layer, and talk about that later. And it also retrieves the data from the model and returns it formatted to the view, which will then display it on the screen. And what we want to achieve here is to keep these presenters clean from framework-related stuff, because we would like to test them without depending on instrumentation. And here is the flow in the presentation layer. Basically, we have a view, presenter, and a model, which is in the domain layer. The view would bind to the presenter by calling the bind and passing itself. Then the presenter will execute some business logic by calling the execute upon the use case that are written in a domain layer, and passing a callback, which will listen for a result. The domain would return some data back to the presenter, and the presenter can then process and format the data, because you probably have models with a lot of fields, but only subset of these fields are presented. And in this case, we can actually create view model classes which have a different number of fields or some transformed version of the original fields, and then pass that back to the view in order to display it on the screen. And on this view layer is also where user interaction happens. So when user touches something, performs some gesture, this is a place where it happens, and the responsibility of that view is only to pass that event back to the presenter, which will then know what to do with that event. Okay, and I'm going to show you some slides, show you some code snippets, and let's pretend that we're developing the app that looks like this, which is basically a Twitter timeline, which is a list of tweets. And I'll be using some frameworks along the way, and unfortunately I don't have a time to go into the depths of these frameworks, but they're really important for the clean architecture. The first one is Dagger 2, which is a dependency injection framework, which will allow you to extract your dependency creation code into some modules, create a graph of it, and then provide the instances of these dependencies in other part of the system where you need it, by using different injection types like constructor injection, method, or field injection. The second one is Eric's Java. This is the reactive programming, of course, for Java. It will make a lot easier for you to work with streams of data, and also on Android, which is really cool, it will make your threading a lot easier. And the last one is just a syntactic sugar, which is a retro lambda. It will allow you to use the lambdas on Android. Okay, and I want to point out here on this slide that the clean architecture reaches its full power if it's used with the dependency injection framework, and I recommend you to use the Dagger 2, and if it's used with the Eric's Java. And you'll see in the future snippets that I'm using the Java across the stack that includes all layers, including the domain. Okay, let's show some code. First of all, we're working with data that looks like this. It's a timeline, which is basically a list of tweets. And those familiar with the MVP knows that view and presenter doesn't talk to each other directly. Instead, they're doing that via interface. And therefore, we need to define two interfaces. The first one is for view, which extends some base MVP view. This is not an Android view. And defines method that will allow the view to actually display some content on the screen. And in this case, we have a list of tweets or error message. And of course, we need an interface for a presenter as well. Therefore, we're going to define the timeline presenter interface, which extends base MVP presenter for the previously defined view. And it also defines two methods that will allow the presenter to react upon the user input on the previously shown screen. Okay, now the implementation. In this case, the view is implemented by activity, but it can also be implemented by fragment or other views that you made. It implements the interface, which is timeline view, and since it implements that interface, it needs to implement both of these methods, and I won't go into the depths of these methods because I believe that most of you know how to write some of these. The important part here is that the presenter is injected to this view, and we will bind to that presenter by calling bind and passing the instance of the view, which is this in this case. And as said on an earlier slide, the job of the view is to pass the user interaction events to the presenter, which will then know what to do with that event. And this line is doing exactly that. Basically, it passes the onRefresh event to the presenter. Now the presenter implementation. It extends some abstract presenter that you might have, and this abstract class is only here to cut out this boilerplate code for binding and unbinding views, and it also implements the presenter interface that we have defined on a slide before. It has two dependencies that are provided via constructor injection. The first one is not that important, it's this navigator class, which basically encapsulates the navigation logic. The second one, the second one is important, and this is your business logic code. So this is the use case which implementation is written in a domain layer. And we need that use case because we are going to get the timeline from somewhere, and this business logic know how to do that. Okay. And when bind happens, you'll call that business logic by calling the execute upon that use case and passing us callback, which in my case is subscriber, and I'll talk about that a bit later. And of course, the presenter would act upon the user interactions. And for example, in onRefresh, we will re-execute the same use case, considering that we have unsubscribed first. And on tweet selection, we'll probably want to navigate to some tweet detail screen. And this is the callback. Okay, as you see, in my case, it extends the reactive subscriber. It's not a custom callback, but that's not important for this slide. What it is important that we have two methods. The first one where we're going to get some data, and this is a timeline, and then we'll tell the view to display that data on the screen by getting the view and telling it to display something on the screen. And here's the place where you can also process the data and format it into any other version that you want to be displayed on the screen. And the view job is then only to bind these fields to text views, image views, and so on. And of course, if error happens, then you'll format some error message from that exception and tell the view to display that on the screen. Domain. Domain layer is the actual brain of this clean architecture because all the use cases and all business logic is implemented in this layer. And as said, it's called, use case is called from the presentation layer by calling the execute upon the use case and passing some callback. The use case works with models, and for data, it talks to one or multiple abstractions. And it talks to abstraction because the use case doesn't care where the data came from. It only cares that data is delivered back to him. And that knowledge where the data came from is actual implementation of your data layer. And once when data is delivered back to the use case, you can perform some business logic upon it and pass that result of that use case back to caller by using callback methods. In our case, this is on next with data on or on error with exception. And I'll show some code snippets for each of these boxes. The first one is a model. There's nothing special here. These are plain old Java classes, not cluttered by any framework or library specific code. And we have tweet timeline, which is a list of tweet location, regions, and so on. The use case is the interesting part. Yes, it's also interactor in my case. This is, if you have looked previously on the Google and searched something for clean architecture on Android, how to implement that, you'll see that most of the interactors are defined like this. Basically, it's an interface with a void execute method that accepts a callback for a certain type, which is your result of that use case. And that's okay. I don't have anything against that approach. But as I said, I like to keep my all the stacks reactive. I will keep reactive programming across the stack, and therefore I'm defining my interactors like this. And basically that's a same thing, void execute method, but instead of a custom callback, we're going to pass a subscriber, which is reactive subscriber, of course. And additionally to that, I define one more method, which is an execute, which will transform the job of the implementer of that method is to transform the business logic execution into a stream. And I'll show why that is useful in a code snippet in future slides. Okay, now the contract. We'll usually have some abstract use case, which every use case needs to implement. And it has some boilerplate code that's done here. And the first thing is that we have is this injection of threads, because by default, you don't want your business logic to be executed in the calling thread. You want this business logic to be executed in some off thread, and this first dependency thread executor actually explains, will provide the thread where the business logic is executed, and the second dependency provides the thread where we're going to listen for a result. And the important method of this class is this create observable. And the job of the implementer of this method would be to transform the business logic execution into a stream. The execute methods would call that create observable, and since it's a stream, they will apply the schedulers, which are passed via constructor injection, and subscribe the subscriber, which is passed via parameter. And also, we'll store the subscription in a field because we want to provide unsubscribe functionality upon the use case itself, besides the possibility to unsubscribe from the passed subscriber. And the second execute, which needs to return the stream for this use case, it basically returns whatever this create observable creates. Okay, the implementation of this get timeline use case, finally. Okay, it extends the use case for a timeline. That will be the result of this business logic. You can also wrap it in some generic class like interactor response or something like that. Since it needs a timeline from somewhere, it will also depend on timeline repository, which is an abstraction for a repository, which is provided via constructor injection. And as you see in create observable, there is no specifically hard business logic here. It's only passing a call to the repository for getting a timeline. And this is how that repository looks like. But as you see, it's an abstraction. It doesn't have any implementation Java interface that defines what the repository implementer needs to have. And depends on what you're building, you'll have some business logic classes. And in our case, let's say that we have a business logic class that knows how to map a location into a region. And it's called the location operations, and I'll refer once more to this class in a future slides. Okay, let's say, let's take a look at a bit more complex example. Let's say that we need to build a feature which is called the regional timeline, which is a timeline, again, a list of tweets, but for a specific region. That means that you need a location first. And the logic would go something like this. You'll try to fetch the current location, and if that's not available, then you default to some default location. And once the location is available, you'll calculate the region from that location. And finally, you'll grab the timeline for that region. And the question here is how to write a use case for that, how to convert that business logic into a stream of data. First of all, you'll need to notice that we have a nested use case inside this big one, and that use case for getting a location. And once when you have a location, the second part is a business logic, which will know how to map it to a region. And all of that together is the actual get regional timeline use case, the one that we need, that we want to write. So let's first write the nested one. Okay. We call it get location use case, and that extends the use case for location. And since it needs location, it will also depend on a location provider, which is abstraction, which knows how to get a location. And in this create observable, we are performing something that's called the shortest path. Basically, we will concatenate two streams. The first one is for getting the current location, and the second one is for getting a default one in that exact order. And then we are taking whichever one is not null. And that means if the current location is available, the second stream won't even be called. And this is that abstraction for a location provider. Again, just an interface that defines what an implementer of a location provider needs to have. Okay, back to the big picture. Now when we wrote that get location use case, let's write the big one. Okay, and we have three dependencies. We have a dependency on an existing get location use case that we just wrote, because that's the business logic that knows how to fetch a current location or default to something else. And we don't want to rewrite that again here or in any other use case which uses a location, because that would be duplication of code. And then we'll need to map that location into a region, and therefore we have a dependency on some business logic class, location operation in this case. And finally, you'll need to fetch data from somewhere. And that means that we'll depend on a repository for a timeline. All of these are provided via constructor injection, and in create observable, we are calling this location use case and transforming it into a stream by calling the execute upon that. And then we can apply different RX Java operators, map and flat map, and manipulate the result of that smaller use case inside this wrapping one. And all of this looks ugly, but if you're using retro lambda, once again, it can be transformed to this, or alternate form of that is this. It's really short, and once again, what are we doing here is reusing the existing use case by calling execute, transforming it into a stream, and then map it with a business logic, which will know how to map a location into a region. And once when we have the region, we'll transform that stream and pass that region to something that will know how to fetch the timeline, which is this flat map. OK, the data layer. As said before, this is where your data provider implementations are and repository implementations are. Basically, this layer is based on the repository pattern itself, and these repository implementations are implementation for the abstraction that's defined in a domain layer. And this repository also has a reference to another abstraction, which is a data source. An implementation of that is a concrete data source, like network, database, disk, and memory, and you'll probably have only subset of these. And this is where your library is. This is the node. So this is where your retrofit code is, where your ORM library, if you're using a database, resides, where you can have one or multiple caching strategies as well. An alternative approach to that is that the repository doesn't have direct reference to the data source. Instead, it can have a reference to a data source factory, which will know how to create the concrete data sources at a specific time. And this factory is here only to encapsulate the logic that decides which data source are we going to use. It can be something like check if cache is valid, and if its cache is valid, then return disk data source, and if cache is not valid, then return network data source. But the repository can have direct references to data sources as well. Whoa. I'll show some code snippets for this. I have a microphone. OK. Data source, as said on the previous slides, it's an abstraction for a data sources implementation. It defines what the data source needs to provide. And let's take a look at the example of one of these, and we'll take a look at the example of a network implementation, which implements the data source, and it has references to the Twitter API, which is an API because it's a network. We'll need to hit the API, and a response mapper, which will know how to map these responses that are returned by the API into a timeline. Both of these are provided via constructor injection. And when someone calls the get timeline upon that data source, you'll call the API. And here's also the place where you can perform different mapping logic or retry logic. And as you can see on this code snippet, we are retrying 3 times with a delay of 500 milliseconds. And once when we have the result, we can map it by using this mapper class into a timeline and return that. And this is that magic Twitter API. I believe that most of you know what it is. It's an interface for a retrofit library by Square. OK, and now the far most code-heavy slide of the entire presentation is the repository implementation. First of all, we have dependencies on 3 data sources: the network, the disk, and the memory. All of these 3 are provided via constructor injection, and when someone calls the get timeline upon that repository, we will again do something that's called the shortest path, where we are going to concatenate 3 streams. One is for memory, the second one is for disk with save, and then the third one is network with save. And we're going to take back a result from whichever is not null, but you can apply any other predicate as well. Where the memory talks to the memory data source, asking it for a timeline. Disk talks to the this data source and asks it for a timeline, and then if some data is available, it will persist it into memory. And network will, of course, call the API, and when data is returned to you, it will cache it both in disk, for example, and in memory for future use. What this concatenation means that if memory has something, then the disk and network won't be even called. And in the worst case scenario, when the memory doesn't have anything and disk doesn't have anything, then we'll hit the API. Data mapping. That's something that I want to talk about because it's really important for the clean architecture, because the responsibility of the outer layers is to map the data into representations that are understandable by inner layers before crossing that boundary. And the usual mistake that developers do is displayed on this slide. Basically, we'll define at the start of a project, we'll define something like this, which is a plain old Java class that defines what our tweet is. This is our core business logic element. And in clean architecture, this will reside in our domain layer. Okay, and someone writes a networking code and uses JSON for serialization, and they transform this same object into something like this. And now we have these @serials@name annotations, which are defining how these fields are named in their JSON representation. And also, because of the limitations of JSON library, you need to have no argument constructor, so we need to add this one as well. And later on, you are writing some database code, and you decided to use some ORM-lite library, and you'll transform again this same class into something like this. And now you see that we have these @column annotations, @primary key annotations, and on top of the class, it's @table annotations. And now, of course, we need to extend something that's called the base model, because the ORM-lite library is making us to. And as you can see, that it can get pretty messy pretty fast, and it's really fragile in terms that someone that changes the naming of the ID or the author, it can easily break your network serialization or reading and writing into database, or both. And the solution for that is to have the entity for each of these layers. So in the clean architecture, we'll have a tweet residing in our domain layer, and API would have its own entity with its own annotations, and database would have its own entity. And the key here is to have these mapper classes which know how to map each representation, like API tweet to tweet and database tweet to tweet. And of course, your response can be completely differently structured thing, or maybe you're merging a few responses, and then you'll have the response mapper as well that will know how to create your API entities. And the tricks that I'm using here is to write these classes as something that implements function 1, or you can wrap your existing mappers into something that implements function 1, because then your mapping would be a one-liner by just passing the instance of that mapper to Eric's Java map operator. And the complete flow of the complete architecture, shortened. Okay, I have 10 more minutes, thank you. We have a view which will bind or pass the touch event to the presenter, and presenter will call the, whoa, that's not what I want to do. Presenter will call the use case, which will execute the business logic and talk to abstraction for some data. The implementation of that abstraction is a repository, and a repository will talk to the data source. And in this example, let's say that we are talking to the network. The network will return some result back to us. Repository will map that result, and it can decide to cache it somewhere for a future use. And then pass that result back to the use case, but before passing it, it needs to be mapped into an object that's understandable by the domain layer. Use case can perform some business logic upon that result, and create a result for a caller, which is a presenter, which will then create a view model class, and pass that class to a view, which will display the data on the screen. And the first reaction of the developers when they're going to this clean architecture, okay, I need to write so many classes, there are so many abstractions and things, and that's true, but all of these classes has a single responsibility, and by depending on abstractions, you're actually creating advantage for yourself, because you can swap the implementation details really easily. And I want to quote Uncle Bob on this one, and he said, make implementation details swappable. And by having these layers and abstraction, you can do exactly that, because on the view layer, you can easily swap your implementation details, how are you receiving the input from your user, and you won't affect the business part of the system or the data layer as well, because they don't see that part. And on the other side, because you're depending on an image loader, you can swap from Glide to Picasso, for example, or maybe business logic has changed, and then you don't want a continuous location, you want a fixed one. And maybe some library gets deprecated, like ORM library that you're using, and you want to swap that one with a new one that has a better performance or something else. You can do that easily. And the other part of the system, again, won't see that changes, because they are referring to that abstraction, and they don't know what the implementation of that is. And of course, in your manual testing or tests in general, you'll try to not use the production payment. You'll switch it with a fake one. And if you're developing some feature that's not implemented on the back end, you can use the local mock instead. The last thing that I want to talk about is packaging, which is not strictly related with a clean architecture, but it's really important for the architecture. And basically, we have two approaches here. The first one is to go with package by layers, where our packages are layers, and implementation classes for features are spread out all over these layers. And the second approach is to go with package by feature, where packages are features and layers are done by classes. And each of these has its pros and cons, and I'll talk about that. Package by layer. The nice thing here is that we can develop each of these layers like a separate modules. And this has a pro that someone can accidentally use something from other domains. So it ensures the dependency rule. And of course, since domain is a Java module, its testing can be unit-based and really fast. And it's possible to reuse these modules in other projects if you have like a desktop app. But the con of this approach is that you have to maintain a versioning for these modules, which can be time-consuming. And you can say, OK, I'll stick everything into one module and do my layers by packages. So we'll have a data package, then a domain package, or presentation package. And that's true. Now you don't have that overhead of maintaining and versioning. But now you can actually break, if you're not careful, the dependency rule and use something from data layer, for example. And both of these has the same con, and that is that here each feature has its implementation spread out over multiple categories, which are loosely called implementation categories. And usually to change some feature, the changes needs to be done across all of these packages. And that's something that you'll probably find on the net when you have the activities package that has all the activities, adapters package with all the adapters. Then on this slide is shown the repository package, which will have all the repositories for our app. And these are all items of the same type, but are not correlated to each other in any other way. So the solution to that is a package by feature, which will, in this package by feature, will use the packages to reflect the feature sets. And this will result with the packages with high cohesion and high modularity. And the coupling between the code will be really, really small. The pros, of course, are that feature changes will usually affect the single package. And maintenance programmers that are brought to the project need to do a lot less searching for a feature that they need to fix or update. And what I consider, and I believe that is the most important pro of this approach, is that scoping is by default package private, and that means that you would expose publicly only the parts of the code and components that you want other features to use and see, and everything else is package private for that package. So my last advice for you today is to go with this package by feature style, because the package by feature still honors the idea of separating layers, but that separation is implemented by using separate classes. That's all. Thank you. I'll be glad to take any questions now.
Hi. I'd like to ask a question about the size of the app and probably retrofitting this architecture on legacy code and on big projects specifically. So, can you tell me what is the biggest project that you apply this architecture on, and the challenges that you have with implementing this?
Yeah, we have some projects and we are applying it. We're in the process of applying that because not all our developers are familiar with this approach. And whoever tells you that he has this clean architecture on all of his projects, he's lying, because he doesn't have. And it's a process. If you have an existing project, you'll need to do this carefully and migrate part by part. And that's, it's a long period, but finally you'll get there somewhere. So that's what are we doing. We don't have everything written in this clean architecture, but we're trying to write the now with biggest components of our app into this clean architecture approach. Yeah, but we still have the legacy projects that have like coupling all over the place, like everyone else, I believe. Any other questions?
Hi, thank you for your talk. So I was wondering to know what will you do if you have something like, I know, get all the tweets, I know, check location of these tweets. After that, you just, I know, applying some filters for that, and so on, so on. You will get really, really big classes with a lot of injections of previous usage of your use cases. So how will you?
Okay, so the question is, what if we have we're fetching a timeline and then performing some different operators like filtering upon that? And if that's a business logic of your code, then I'll write the use case for that. You can easily do that with if you have an Eric's Java across the stack, because especially the filtering is really easy. You'll fetch the data, of course, for some repository that knows how to get data from somewhere, and then you can perform that business logic code inside the use case, applying all these different filters and probably merging something. Does that answer your question?
So what I see is that every time you apply something new operation, you will get much more callbacks through the stack of use cases, yeah?
Yeah, I don't know, actually. I don't believe that that's true. You only have, like...
and if we need to switch the order, for example, in this case, it's not...
I understand your question now. Okay, the question is, what if we have like different representation? Let's say that we have a list of something and we can sort that by alphabetically by like, I don't know, ID or something like that. Then you'll create some specification which will you pass to your use case. This is something that's like a query for the use case. And then use case can check that specification, whatever it is, and then sort the data as needed and then return it back to the caller. That will be the solution to that problem.
Okay, thanks.
Any more questions? No. Thank you very much, Marko.